Today, we'll think about what happens when the x variable is not continuous, but categorical. For example, unordered categorical. So we know that y has to be reasonably continuous because of the assumption of the normal distribution, right? So we know the epsilon is normally distributed, and we have shown that y also needs to be normally distributed. There is, however, no requirement that the x variables have to be continuous. They can be anything. And including, they can be categorical. Categorical variables are frequent. For example, gender, male, female, Canadian provinces, favorite color, Canadian political parties, type of alcohol. There are many such variables. And one thing you could do is, because the numerical calculations, of course, do not accept text, they require numbers. So you could assign numbers. So you could say, well, 1 if color equals red, 2 if color equals yellow, 3 if color equals blue, 4 if color some other. Then we can run this in a model. I only specified one x variable, but you can, of course, add others. And the software will go its merry way and compute the result and will not complain, right? Because the software just does work. All right, so then we get some answer of beta 1, whatever it may be. And so then we start interpreting. When the color is red, y increases on average by beta 1, whatever we estimated for beta 1. When the color is blue, y increases on average by 3 beta 1. So what we're saying here, or what we are telling the model, is that the effect of blue is 3 times that of red. And that does not make sense. And it's for that reason that we need to find somewhere how to integrate unordered categorical variables into the regression models. And those unordered categorical variables occur much more frequently than continuous variables. This is, of course, also useful for ordered categorical variables because, or what's an ordered categorical variable? Education has high school, has college, less than high school, postgraduate degree. If you code that in 1, 2, 3, 4, high school being 2, less than high school 1, even though it's ordered, we don't know that the effect of high school is twice that of less than high school, right? Okay, so that's enough for the motivation, and this ends this segment.